All right, so we have two of these pieces of aluminum here that I'm going to use as brackets to hold the first cross slide assembly to the base plate. And so there's going to be two 1/4 20 holes 4 inches apart, and there will be 3 holes drilled and countersunk for M4 screws, although I think I'm only going to be using 2 screws for now. I don't think the other one's necessary. I'll just add it in case we need it, but I think it's going to be fine. Next up, we're going to drill the M4 holes. This is the bottom of the part right there, but these guys are going to be oriented like this, and I need a specific height from the bottom to center on that. It's sort of a T-slot in the side of the aluminum housing, so that's what we're shooting for. Here's the finished parts. All right, so here's where we are so far. I think I have 2 sizes of M4, 15 millimeter and 10 millimeter, and I think I need 12. So I think this is too long, but just as a test, we can put it in here. And I'm not going to put the other side in yet, but let's just see how things go together. I guess I could start this side here. And then that one will go there, and this guy will go here. That looks like it's a good fit. And it looks like these are going to be too long. Let's see. Can you tighten it all the way? Nope. It's like literally a couple millimeters too long. Yeah, the screw's hitting the back. That's hilarious. So the 1/4 inch line up pretty nicely. Wow, even without these screws holding anything, that's in there. I didn't think that was going to be such a tight fit, but it actually is. That worked out really nicely. So when I get the right size screws, that's definitely not going to go anywhere. And it looks like it's sitting flat the whole way, which is good. I think we're good. Look at that. That's tight. So looking good. Just need to get the next size down screws, or I need to cut these screws down. I can build a fixture to do that. That'd be a side project. We love side projects. Next up, I got to make a bracket that fits up here that mounts on this piece that will allow the other one of these units to slide in this direction. And about 3 inches tall. Next up, we're going to cut a slot down the middle of this piece. It's going to mount on one of these with 4 holes like so, and it's going to fit another one of these like so with a 1/2 inch on each side. And then we're going to drill some holes in here to meet up with the T-slots here to hold nuts in the T-slots. And that's how we'll hold it. That allows you to position this back and forth, which is really valuable since we're not exactly sure where every part's going to end up on the laser. So as much flexibility as we can get is useful, especially since they didn't buy worm screws assemblies as long as they probably should have, so that they could cover every option. So instead, we got to make the whole fixture flexible. I'm using a zircon nitride coated end mill, and I'm using a Welding flat based holder. Even though this end mill does not have a Welding flat, I did bottom it out and tighten the set screw pretty nicely. So my problem though is not having the end mill go that way against the stop. It's actually having to get it sucked out of the holder with a standard R8. It happens all the time. I don't know why, but the force tends to pull them right on out of the holder. I haven't had the problem with the Welding flat holders, even when I'm not using a Welding flat end mill, so we're gonna see. I'm gonna try and take a 1/2 inch bite out of this. We're gonna go total depth 3/4, and then we're gonna go extra 0.5 something each direction to get the width correctly. Total depth is going to be 3/4 of an inch, but I thought I'd try this. Too slow. Who would have thought, huh? Yeah, it's cutting through it like butter. What I don't want to let happen is have chip packing occur. That went much easier than I thought it was going to. With smaller end mills, I've had serious chip packing. Except where it chattered there in the beginning, very smooth edges, smooth walls too, so that actually worked out pretty good. I want to double check the depth, so we're going to get a depth mic, and I'm going to measure this just to know where I'm at, because my DRO says 0.4996, but I was only roughly estimating the top of this, so I'm going to get it closer to exact. You know, again, I don't need any precision for this. I'm doing this as a training exercise for myself. So this looks like we're at 0.507. So we'll type in 0.507 here. Let's go to 700. So this is 200 thousandths depth of cut, already in a deep groove. All right, let's go for, I'm going to leave 5 thousandths at the end, or 10 thousandths. Let's leave 10 thousandths. So we're going to go to 740. Just for the heck of it. I want to see how close I am to matching. Wow, 740 like in 2/10, and that says 740 and 7/10. All right, I'll buy that. So that's looking good. So now we're going to just do some of our offset cuts. One thing I've been keeping an eye on, you'll notice how clear the deck is. There's no, well, there's a little bit of groove, so it looks like it sucked the end mill out a little bit. So I'm going back and forth, taking off the final bit of material. And when I'm all done, I might need to add a couple thousandths because this is going to be really tight. This is exactly the width, and I'm not giving myself any room for play here, so we might be going and taking another couple thousandths off. So just taking a measure, should be 0.535 plus 1.5, I'm sorry, 1.57. Oh, looks like we're a thousandth under? We're a thousandth and a half under. That's hilarious. All right, just for the heck of it, means I shouldn't be able to fit this thing in there. And sure enough, it is too tight. I think I should add a couple of thousandths aside, taking off 2 thousandths more aside, which should put me 1 thousandth over aside, maybe 1.5 thousandths over aside, maybe 3 overall. We got ourselves a good fit here. Interestingly enough, the end piece here is a little bit wider right here. They made the material a little bit wider, which is problematic actually if you want to slide this guy in. So if you want to put the T-nuts in there and still slide this in, you can't. But this now has a couple thousandths play, which is exactly what I was looking for. Still very smooth and nice. Now I got to drill and countersink the 4 holes to mount into the bottom slide. Okay, that's those 4. Now we need to do 2 on each side here. Now we got the part on its side. We're going to drill the 4 holes and countersinks for the screws that go into the other slide assembly. So the bottom holes, the holes go in this direction, mount into the bottom slide assembly, and these holes hold the top slide assembly into the T-nut slots. So I'm switching out my regular handle for the Tangent Engineering wheel because I got to do a lot of drilling, and this is just fantastic for drilling. I don't know if you've noticed this, but this stop I made a long time ago is fantastic for repeat work. Got the idea from Tom Lipton. I've been using it ever since. Works extremely well. I have a Belleville washer with a screw. This is ground on both sides, so it pressed against the ground face here, and it slides very smoothly. You can get a part within a thousandth pretty easily, repeatably. Now I'm going to remove a little bit of material, about 3/4 of an inch down, because this end piece sticks proud of this, which means that it can't slide into my aluminum piece. Both sides are now smooth and flush. Perfect. So that piece will slide in when you have the T-nuts in place. We had a little precarious setup. I've got this side clamped really tight, but it's just in the edge of the jaws because this thing is in the way, which I could move back incidentally, but I just supported this other end, got it roughly level. Even if it's not exactly level, all it would do is change the depth of this cut here, which is no big deal, as long as I'm more than the 3/4. As a matter of fact, before I walk away from this, I should probably test my other part. So should come right off the end, which it does very easily. Perfect. So see, this part has these screws that pull into a nut that fits in this slot here, and it's just a square slot, so they grab in there, and then this piece, these 4 holes, catch in the cross slide below it, or whatever you want to call this, and that's it. All right, so here's the bottom piece. I don't have the right screws for the side of that one. This guy fits up here, and I do have the right length screws for this, so the other ones are on order. Now at some point, this is going to need to be dialed in to make sure that this is sitting perpendicular to the direction of motion of this guy, so at least when they're doing XY, they're perpendicular motion rather than some angle. For now, I'm just going to snug these so that I can show you how this goes together. So then you would preload the screws and the nuts in this, and then you'd slide this piece on there. And I think the bottom piece isn't attached right now. I'm pretty sure you want the center of gravity around here. So now all I need to do is make the plate that fits on here, which is going to hold the part to be welded. And then, of course, we got to wire up all these to the controller and test it out. All right, so I've preloaded some of these screws with nuts. I think you can see them with these square nuts that hold these guys in the slot. And since I removed a little bit off the end of each one of these so it no longer sticks proud, then I can just slide these guys on here, hopefully. There we go, there's one. There we go. And so I can set this guy here now. So ideally, I'd want this cross slide piece here to be perpendicular to this plate in this direction, or parallel in this direction, so that it would travel exactly perpendicular to this edge of the plate over here. And then this guy, when I mount it up here, it needs to be set up so that it's perpendicular to this guy. That's the most important of all. The other two relationships are having to do with the table and the laser itself. But if the laser is just a point in space, it doesn't really matter where that point in space is, as long as these two slides are perpendicular to each other. So that's the really critical measurement. So let me start by tightening these guys. All right, that's one. Now the other one, I need to do the same thing so you can actually see this one. This one actually does need to be perpendicular, pretty accurately so. Has two adjustments, this base plate and these guys. Hopefully, I got everything close enough that just simply these nuts here will hold it in place perpendicular. So again, because I took a little bit off the end here, this guy can now slide over these nuts, which is very handy. And I made this a pretty darn close fit to begin with. There we go. That's pretty solid, and that lets this plate go way over that edge there. So right now, I'm going to try and use this square here. I've got an adjustable parallel down here, which I can fit against the bottom slide, which hopefully is moderately accurate. Press that up, and press this guy in. By the way, as a nice touch, McMaster Cars sells Allen keys individually in almost every size. Well, more sizes than I've ever actually seen. And they're really inexpensive. The small ones, like this little metric 3mm, was like 30 cents or something like that. And this 3/16 for quarter 20 bolts was like 50 cents. So I bought extra when I bought this hardware for this, specifically so I could leave a set of Allen keys with this assembly so they'd never have to look for them when they want to make adjustments. All right, so we're going to check this out. I've got OpenBuild's control app loaded here, and I've got a demo thing loaded, which really isn't what we're going to do, but this is for actually a laser engraver to engrave the OpenBuild's logo. Ooh, that's not going to work. Got to go to 0 here. My Y0 needs to be somewhere else because my Y-axes are backwards. I need to fix that. Okay, and set my Y0. And let's rerun this. I don't think we've got this scaled right either. Nope. So I don't think this is calibrated right because this is going it's consuming too much of the entire screw, which has a full foot of range almost. It's a little bit under a foot. So we need to calibrate it. All right, so we got a quick setup here with an indicator to see if the step size is accurate. Right now, I'm set to every click as 1,000th, and it looks like it's about double. So if you notice when I went backwards, the other indicator wasn't working. Well, the reason it wasn't working is because the shaft was slightly bent and it was sticking. So now I've replaced it. So this should be 1,000ths. We got this lined up. I know you're a little off angle here. So this should be 1,000th. And it turns out that 1,000th is exactly 2,000ths, exactly double. Well, let's see if we can fix that. We go to the Gerbil settings on this. It looks like we're 620 steps, 640. Let's see. All right, so here we go. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Oh, that's right on the money. Straight up and down. Some of these, like in the in-between, are not exactly right, but that went exactly 1/10. So now if I go here to the 10th change, I should be able to go, No, that's sorry, that's 10 thousandths. 10, 10, 10, 10, 10. Right on the money. Here's 1/10 of an inch. We're gonna go 10 at a time here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Tiny bit under. And it starts to get worse. Okay, so maybe it's 160. I was counting, I was reading this bottom 25 as my set point, and it turns out that it was not particularly accurate on the indicator. All right, so we got adjusted with the course settings. We actually had to go up a little bit. Here we go, 10, 20, 30, 40, 50, 60, 70, 80, 91, 10, 20. And that's within a couple tenths right there if the indicator is accurate. The problem is the indicator is non-linear across its range. But that seems pretty darn accurate now. So I think we're good. I think we got our calibration setting 161. Need a better indicator, got to get that Michutoya fixed. All right, so I think we're done. We got this calibrated now. So I think the next step is to take it down and see if if it works for the people I got hired to make this work for. I think we're good.